Hello, and welcome. Today, we're going to pull back the curtain on a really cool system called POPSI. That stands for Postulate-Based Permuted Subject Indexing. I know it's a mouthful, but think of it like this. It's basically a universal grammar for organizing information, a super logical way to find exactly what you're looking for. So let's start with the big question, the one that librarians and information scientists are always trying to answer. How in the world do you build a system that has strict, consistent rules, but is also flexible enough for any person who walks into the library? That's the puzzle, and POPSI is the solution we're going to explore today. All right, here's our game plan. We'll start with that indexing puzzle, then get into the ideas behind POPSI and its 4 main building blocks. After that, we'll see how you actually put a subject string together, walk through a real-world example, and finally, we'll talk about its basic versus specific versions. Let's do it. Okay, first things first, the puzzle. You see, the real challenge with indexing is finding that perfect sweet spot between a system that's logical and one that's adaptable. You've got to have rules, but they can't be so rigid that nobody can find anything. It's a real balancing act. So let's talk about where POPSI even came from. This system didn't just appear out of nowhere, you know? It was built on some seriously groundbreaking ideas in library science. It was a huge leap forward in how we think about subjects. All right, so the story really kicks off back in 1964 with the legend himself, S.R. Ranganathan. He had this game-changing thought. What if we could take facet analysis, breaking a subject down into its basic parts, and use it all by itself without tying it to a classification number? That was a huge deal. This idea got the ball rolling for researchers at DRTC in Bangalore, and that's where Dr. Ganesh Bhattacharyya stepped in. He took that tiny seed of an idea and grew it into the full-blown system we now call POPSI. The theory at the heart of all this is something called the deep structure of subject indexing languages, or DS-SIL. And here's the big aha moment from Bhattacharya. Just like all human languages have some kind of shared underlying grammar, all indexing languages have a common logical structure. POPSI is built on that universal grammar, and that's what makes it so powerful and consistent. Okay, so if we're talking about a grammar, then what are the words? Well, POPSI gives us 4 basic categories. The best way to think about them is as the fundamental parts of speech for any subject. If you get these, you'll get the whole system. First up, we have discipline. This is the context, right? The big picture field of study. It's the setting for our subject sentence. Are we talking about physics, biotechnology, or, for our purposes, library and information science? Next is the entity. This is the noun of our subject. It's the main thing, the core concept we're actually talking about. It could be something you can touch, like plants, or something more abstract, like energy. It's the star of the show. Then we have action. This is our verb. It's the doing part. Now, this could be an action the entity is doing itself, like birds and migration, or it could be an action being done to the entity, like treatment or organization. And last but not least, property. This is our adjective. It's a quality, a characteristic of the entity or the action. Think of words like efficiency, utility, or power. It just adds that extra layer of description. But wait, what if we need more detail? That's where modifiers come in. And you've got 2 flavors. On the left, you've got common modifiers. These apply to the whole subject, like a place in India or a time, 19th century. On the right, special modifiers are laser-focused. They apply to just one part, like specifying chemical treatment or saying something is done using computers. Okay, so we've got our building blocks: discipline, entity, action, and property. But you can't just throw them together randomly. We need a blueprint, we need rules. And that's exactly what POPSI's syntax gives us. It makes sure every indexer builds the subject string in the exact same logical order. And the rules are so wonderfully simple and logical. Discipline always kicks things off, followed by the entity. A property or an action always comes right after the thing it's connected to. A part follows the whole it belongs to, and a modifier, you guessed it, follows the thing it modifies. It's this consistency that makes the system work. Now, to make this assembly even easier, we have the POPSI table, and I need you to listen closely here. This is super important. This is not a classification system. These numbers aren't like Dewey decimals. Nope. Their only job is to put the terms in the right order. Each component gets a number, and that tells the indexer exactly where it goes in the line. It's a simple idea, but it's incredibly powerful for keeping everything consistent. And here's the whole process, from start to finish. It's these 7 steps that take you from just looking at a document to having a fully alphabetized index. Some really key steps in here are standardization, where you use a special kind of thesaurus to pick the right terms, and modulation, which is where you add in broader terms to give the user more context. Okay, enough theory. Theory is one thing, but seeing it work is another. So let's take an actual document title and run it through the POPSI ringer to see how all these pieces fit together in the real world. So here's our title: Use of Computers for Indexing of Educational Films in University Libraries in India. Wow, okay, that looks pretty complicated, right? But with POPSI, we can break it down, piece by piece, into its grammatical parts. No problem. First step is content analysis. We just go through and assign each concept to a category. You'll notice that library and information science is the discipline, but it's implied, it's not explicitly in the title. University libraries is our main entity, educational films is a part of that entity, and indexing is the action being done to that part. Then, computers and India are our special and common modifiers. See? Totally doable. So after we go through those other steps like standardization and modulation, where we've added those broader terms like libraries and information sources for context, we use our syntax rules to build the final string. And this is what we get. You can see how everything is ordered so logically, from the big discipline down to the tiny details like computers and India. This structure is what makes the index so predictable and honestly so helpful for the person doing the searching. But wait, here's where the real magic happens. We don't just stop at one entry. In step 6, we pick out all these key terms from our string. And that main entry we just built, it's going to get repeated under every single one of these terms. This creates tons of different ways for a user to find what they need, and brilliantly connects related ideas, no matter where they start their search. It's so smart. And one of the most brilliant things about POPSI is that it's not this rigid one-size-fits-all thing. It was actually designed to be adapted for different needs, which was a massive step forward for indexing. So you've got POPSI Basic, which is the general theory, that universal grammar we've been talking about. But from that, you can create a POPSI-specific version just for your library. For example, a medical library might say, okay, for us, diseases is our foundational concept. An engineering library might pick materials. It's all about customizing the system to fit what your users actually need. And that brings us to a final question to chew on. We live in this age of AI and search algorithms. So what's the role for a carefully crafted, human-designed grammar for subjects like POPSI? Does this kind of logical, predictable system still have an important part to play in making sure we find things with clarity and context? It's definitely something to think about. Thanks so much for joining me today.